All right, so let's just start with question. I'm just going to go through 1, 2, and 3. Does anyone have any specific questions they want to ask before we just go over it overall? Okay. So the first question is what are the fewest and the most possible recursive calls made by even odd if passed an array of length n? That is, if A is an array of length n, and you invoke even odd A, 0, n minus 1, what are the and then the next question is what are the characteristics of an array that requires the least or most recursive calls? So I pulled up the code so that we could look at it. All right, so this is the function right here, even odd, and it's a recursive method to put the even numbers in an array before the odd numbers. So the first question that they asked is, what's the least number of calls? So there's two things that we have to look at in recursion. We have to look at our base case, which is right here. And then we have to look at how we're getting to the base case, which is our recursive calls. Here, here, and here. So our base case is if I is greater than or equal to j. So he told us in this scenario that we're going to have some integer array a, we don't know what's in it, an integer I, which is going to be 0, and then integer j is going to be any number. So if for this one, we can make j equal to, supposed to be the length of the array minus 1. So I'm going to say that in our case, n is equal to 10. And I'm going to make j 9. So this is just an example so we can go through the problem and see if it makes sense with that. Okay. So now that we have that, we need to do the least amount of calls. So look at our 3 function calls right here. We have even odd a, I plus 1, and then j, and then I plus 1, j minus 1, and then I, and then j minus 1. So which one of those 3 cases are going to get us to I being greater than or equal to j the fastest? Anyone else want to guess? But yeah, that's correct. The second one is going to get us to our base case of I being greater than or equal to j the fastest. Why? Because it's adding 1 to I and subtracting 1 from j. So if we did that, how many functions, let's say we only went to this else if statement. If every time we call this function, it's going to go to this, then this is going to give us the least amount of recursive calls. So let's say in this scenario that we're making up that we're able to only call that even odd. So if we did that, this is our original, and then we'd have to call it again, a, but now it's I plus 1, so it's integer, it'd be 1, and then it's 9 minus 1 is 8. So who can tell me what the next one would be if we did it again? Yeah. So it's going to be 2, 7, and then it's going to keep going, right? We're going to add 1 to I and subtract 1 from j. So 3, 6. And then 4, 5, and then 5, 4. So when we get to this one right here, we reached our base case, right? Because I is greater than or equal to j. So it'll stop calling the function. So if we looked at that, in this scenario, n was equal to 10, and we had 5 recursive calls. So look at the pattern between what the length of the array was and how many recursive calls we had in our least scenario. So basically what you're doing is looking at the code and trying to see which one is going to get us to the base case the fastest. And then just imagine that there's a scenario where this exists. The second part of the problem is to see what scenario would this even occur in. So does everyone understand this part where we find the least number of calls? Or should I do another example?
Looks good over here.
Okay. You can message me privately no if you didn't understand it, so we can go through it again. Alright, I think everyone's good, so now we can move on to the most. So now that we did the least, the most is kind of simpler. We only have two other options. We know this one is going to be the least number of calls if we call this repeatedly. So if we call, what happens if we call either this one or this one? Then it's only incrementing I plus 1 each time, or j minus 1. So if we do the same thing where we have a is an array, and then we have integer I is 0, and then j is 10 minus 1 is 9. Well, if we do either one of these calls, we're just getting closer to the base case by 1 each time. So let's just say we do this one over here and we keep repeatedly calling this one. Then the next one is going to be A, 1, 9. A, 2, 9. Right? Until we eventually get to A, 9, 9, which is going to be where they're equal. So then again, look at the relationship between what n is and then what, how many recursive calls we did. So how many recursive calls would it take us in this scenario?
Nine.
Yeah. And even though n is 10 and then the recursive calls is 9, just keep in mind that the specifics don't matter as much and you want to look at the general part. And just think about if you had like a really, really large array, would it really matter? That difference of 1. Okay. And then the next part is going through what scenario would this happen in. So let's start off again with the least number of calls. So we want the scenario that we came up with before where we had n is equal to 10 and then we had 5 recursive calls. How could that happen? So let's look at the different parts of each if statement. So this one right here is if a of I modulus 2 is equal to 0. So we know I is equal to 0 in our scenario, right? This is equal to 0. So it's going to start at the beginning of the array and increment up. And if it calls this, it's going to go I plus 1. So it's going to go 0, 1, 2, 3, 4. So that means that the beginning of the array would have to be even, right? All right, how about this else if statement? If it says a of j modulus 2 is equal to 0, what does that statement mean? The end of the array being even. And then finally, the else statement would be the end being odd, right? Okay. So now we said before that for our least scenario, we only want to call this part right here. So for this to happen, the end has to be even. But does anyone notice anything else that needs to be true? Let's look at this. If we go to the else if statement, before we get to this else statement, we have this if statement, right? So if the if statement is true, then we're not going to be able to get to this else if statement. So we need the first if statement to be false. So what does that mean if the first, yeah, it needs to be odd, exactly. So we would need, for the least case to happen, the beginning would need to be odd, and the end would have to be even. And also keep in mind that we start at I as 0, and then we're starting as j as n minus 1, right? But when we're incrementing, it's going to keep going up. So it's going to be 1, 2, 3. And this is going to be n minus 2, n minus 3. Until there's some point in the middle. So especially if we're calling this one, then it's going up by 1 and j is going down by 1. So it's not just what does beginning mean and what does end mean. It pretty much, I'll just kind of help you. Think about it as halves, okay? And then for our scenario where we have the most amount of recursive calls, well, all we need to do for it to be the most amount of recursive calls is to go to either this first if statement or this else statement. So you need it to not, anything that's not this will be the most case. So for example, if the whole entire array is even, we just have 2, 4, 6, 8, 10. What's going to happen is it's only going to reach this statement every time until it gets to the base case. Or if we had the beginning, I forgot. Hold on. Basically the opposite. If we had the beginning even and the second half odd, then what would happen? It would start off by doing this one, and then when it stops being even, then it'll be this one. The first one needs to not be even. Okay, that's from before. All right, does that make sense? Only one yes.
I have a question.
Mhm.
So what is the question asking? Is it asking which recursive call is the the one that causes the fewest calls, or is it asking how many calls would it make?
They're asking how many calls, so that's why we were saying, okay, in what scenario would you get the least amount of calls? So the first part of the question is how would you describe the most possible amount of recursive calls and the least possible amount of recursive calls, right? And the second part of the question is how would you have a scenario where you can get to that least scenario? And how would you and what would have to be what would the array have to look like to get to that scenario with the least amount of recursive calls, and what would the array have to look like to get to the scenario with the most amount of recursive calls? No. Shreya asks, do we consider an empty array being passed? No, you don't need to worry about that. Just think about the general ideas. You don't need to think about like every possible scenario, and like don't worry about if it's like if the array is like even odd, even odd, even odd. Just stick to what you know, and in like that one scenario that we understand, which is that when is it the least is only. Yeah, we went over it. I'm not gonna say the answer, but anyway, yeah.
Would we have
Alright,
to, sorry,
no, go ahead.
say it in terms of n?
Yeah.
Okay.
Okay. Any more questions for problem number 1? Okay. So let's move on to question number 2 then. Okay, so this is like a logical question. Anybody want to read it? No? Anyway, I'll just read it then. An evil king has n bottles of wine, and a spy has just poisoned one of them. Unfortunately, the king does not know which bottle was poisoned. The poison is very deadly but slow acting. A single drop in a bottle of wine will kill anyone tasting it, but only after 1 month. By assigning n tasters, one to each bottle, the king can know which bottle is poisoned after 1 month. Design a scheme which allows him to determine the poisoned bottle within 1 month, but with many fewer tasters, and characterize the number of tasters needed as a function of n. With your scheme, what are the smallest, largest, and average number of tasters who will be poisoned on the job? Alright, who wants me to go over what the problem means? Or what the question's asking? No one? Everybody looked at this? Alright, so basically we have this scenario where you're gonna get killed after 1 month. So basically, you can't just have like one guy try it and then see if he dies, and then try the next one and see if he dies, because you're not gonna know for a whole month. So that's why they have that 1 month part in it. And then it says we have n tasters, and the original plan is to have one to each bottle, but we want a new plan that's gonna take less tasters. So does anyone have any ideas? All right. So basically, there's two cases, right? That could happen to a taster. Either he dies or he doesn't die. Or I guess lives. Yeah, you could have the same amount of tasters as the amount of bottles, but that would be you need N tasters. So we want to do something better than having N tasters. We want to have less than N tasters. So if you have 1,000 bottles, yeah, you can have each person have one bottle, and that would be 1,000 tasters. But we are trying to come up with a way to have less tasters or the least possible amount of tasters and still know which bottle is which. So if you have less tasters and you have the tasters drinking more than one bottle, the question is how will you know which bottle they drank from, right? If we split it up and we say, okay, there's 1,000 bottles of wine and each taster is we're gonna have 10 tasters, each are gonna drink 100. Well, yeah, that works, but then you don't know which of the 100 is the poison bottle. So we're gonna go over a way to know which bottle it is and to use way less tasters. So there's two options for what happens to the taster. Either he's gonna die or live. So what does this two option scenario sound like in coding? How can you represent something an if else? Yeah, okay. Okay, a boolean, yeah. Exactly. So somebody said this yesterday, a boolean and if else too, which is kind of the same thing. Those are two scenarios, true or false. But what's another way that you can say a boolean is? Like for example, I'll give you a little hint. If something is true, you could represent it by the number 1, and if something is false, you can represent it by 0.
Binary.
Yeah, binary. So this is going to be like the easiest way to know which bottle it was. So let's have this scenario where we have n is going to be 32. Okay. And we're just going to write out binary for starting with 0, okay? So we're going to try to look for patterns. So if we start off, the first is going to be 0, 0, 0, 0. Does anyone know how to write binary? Alright, anyway, there's a sort of pattern, so just look out. So this is going to be this is equal to 0, right? And then it's going to be 0, 0, 0, 1. 0, 0, 1, 0. This is equal to 1, equal to 2, 0, 0, 1, 1, 0, 1, 0, 0. Does anyone want to tell me what the next one would be?
Zero one zero one.
And then and then 1 0, 0, 0, 1 0, 0, 1. Oh wait, I think we messed something up. Oh, we definitely did. Alright, does that look correct to anyone who knows?
Yeah.
Okay. 1 0, 0, 0, 1 0, 0, 1. Okay. So we just wrote out the first few numbers. 3, 4, 5. Okay. So if we look at this first column right here, you notice that the pattern is 0, 1, 0, 1, 0, 1, 0, 1, right? Oops. Okay. And how about the next one? So the first one is every other one is true. Let's say 1 is true. And for the second one, every 2 is true. And for the third one, every 4 is true. And if we did the full fourth column, if we wrote out every binary number up to 32, how often would the fourth one be true? So if the first column is true every other time, the second one is true every 2, the third column is true every fourth time, what's the fourth column going to be? Yeah, exactly, every eighth. So if we represent these numbers by a person, or by a taster, let's say, and then this is taster 1, taster 2, taster 3, and taster 4. And we say to taster 1, you drink where yours is true. And we say to taster 2, you drink where yours is true. And by the way, we're saying that true is when it equals to 1. And we say that to each person until we get to the number of bottles that we need. So in this scenario, we had 30, n is equal to 32, and we had 4 tasters. So now if I tell you that, let's say in this scenario, only the first guy dies, right? Well, in which number is only the first guy the one that drank it? Okay, so odd ones, yeah, the first guy drinks only the odd one. He drinks every other one, but other people drink some of the other ones. 1 if only the first guy dies. Yeah, so if only the first guy dies, then it has to be this row right here. Because he's the only one who drank that bottle and everyone else didn't drink that bottle. So true 1 means he drank it, and 0 is they didn't drink it. So if I tell you that the person that died, that person 2 and person 3 died, then which bottle was it? Six, yeah. So if we look at the number where 2 is, in column 2 is true and column 3 is true, this is the only place where it's both true. So if person 2 died and person 3 died, if they all live, then bottle 0 has the poison. Yeah. Exactly. So if you label basically if you label the bottle 0 to whatever, and then you tell each person drink this bottle, and then you can tell by who dies which bottle is correlated to it. So if n was 32, we had 4 tasters. If n is 64, how many tasters would we have? Oh wait, I feel like
Aren't you missing a column?
This would be if n is 16, right?
Yeah, sorry, I was just thinking about that.
Yeah, that was my bad, sorry. Well, good job, you actually know what's going on, okay. So if n is 16, then we'd have 4 tasters. This is if n is 16, the scenario I drew right here, I just accidentally said 32. So this is if n is 16, we'd have 4 tasters. So if n is 32, how many tasters would we have?
5.
Mm-hmm. Exactly. So try to see the pattern between, and then if it was 64, we'd have 6 tasters. So what's the pattern between what n is and how many tasters there are? All right, let me ask one more. Okay, everybody answer. Okay, there's 15 or 14, 13 of you or something. So if the second guy dies and the fourth guy dies, then which bottle was it? Yeah, the 10th bottle. This guy drank it and this guy drank it, and they're the only ones that both drank that bottle. Yeah, I asked if the second guy dies and the fourth guy dies, which bottle had the poison? And then everyone said 10. Because they're the only ones that both drank from bottle 10. Okay, so anyone have any questions about this? How did I get the numbers? This is just writing in the zeros and one, right? This is just how you write binary. So if I wrote 0 as a binary number, it would be 0, 0, 0, 0. Okay. Yeah, after we go through question 3, I'll probably go over these examples again for anyone who came late. So how do you, okay, yeah, you just write it, you just explain it. So you'd say, okay, I'd figure out how many tasters I need by doing this mathematical, whatever you're gonna put, to get from n is 16 to 4 tasters. And then you say, okay, well, I'd label each bottle by doing whatever. And then I would make each person drink blah, blah, blah bottle. It's just like write out like a few sentences just explaining it. They're not looking for that much. All right, and somebody, okay, let me go back to how to get these numbers. This is just 0 as a binary number. So a binary number is just 2 to the whatever, 2 to the 0 power, 2 to the 1 power, 2 to the 2, and then 2 to the 3, right? So the 1 tells you if you do it. So if there's a 1 there, that means that you do. So let's do this number in binary. If we have the number 0, 0, 1, 1, well, that's 2 to the 0, 2 to the 1, 2 to the 2, and then 2 to the 3. So 2 to the 0 is 1, which means it's true. So so that means it's 1. 2 to the 0 is 1. 2 to the 1 is 2. And then, since this is false, you don't do 2 to the 2, and you don't do 2 to the 3. So then you just add them, and you get 3. So that's how you convert from binary to a regular number. So if you just start writing binary as 0, 0, 0, 0, you can keep writing it up to whatever number you want. You guys don't need to write out every single number how I did. You just need to explain the scenario or explain how you decide who drinks what. Any more questions on that one? All right. So if you don't understand it, please send a no to me. Okay, so we're just gonna do the third question. Because the fourth and fifth ones, I feel like you guys can do that on your own. And also, oh, well, let me go over one more thing for this. They asked for the most amount of people that will die in this scenario, the least amount of people, and the average. So I think that you guys can figure that out on your own, so I'm not gonna go over that and just look at the pattern. Obviously, the least amount of people that will die is no one. Wait, no, not no one, like one person, I mean. If it's the first guy's bottle that got poisoned, if the 0 bottle is poisoned, then, or the 1 bottle, or basically, obviously, if one person has to drink the poisonous bottle at least, so that's the least. And then how you have to think about, for the most, you have to think about n versus the number of tasters versus the number of bottles. Okay, I'm gonna go on to question 3. So question 3 was based on your recursive multiply function. And what did he ask? Alright, characterize the number of recursive calls made by your recursive multiply program in terms of the smaller of the 2 arguments. So this one's not too bad. Alright, so last week when we went over a recursive multiply function, we talked about there's a base case, and then we had a way to get to the base case. So we knew in that scenario in the recursive multiply program that A was less than or equal to B. So he said to look at it in terms of A, so we don't need to worry about what B is. So what was our base case? Does anyone want to write what mainly everyone put for their base case? Yeah. If A is equal to 1, then we just return B. And then how are we getting to A? Most people were doing something where they would do mult A divided by 2. And then whatever happens to B, it doesn't matter. Because we're only worried about A divided, the part that has to do with A. So, for example, if we said that A was originally equal to 8, and we plugged it into this function, like the same thing we did in the even-odd question. If we had A is equal to 8 as our first call, and then B doesn't matter, B is whatever. Well then, what would be our next recursive call? If we plugged it into this function? 4 or something, yeah. So A is going to be equal to 4 and B is going to be whatever. So, because we plug into this function, A does not equal 1, so we have to do this else statement. We had more details about what the else is, but basically every time, no matter if we did the else or else if, it was just dividing A by 2. So now A was 4. And then if we had, and then it goes again because it's calling the function again. So what is A going to be now? And then what is the last one going to be? A, B minus 1. Yeah, it's going to be A equals 1, and then B is whatever. So now we got to our base case where A is equal to 1. So the function's going to end. So we had 3 calls. So when A was, Okay, when a was equal to 8, the number of recursive calls was equal to 3. So let's just do one more. So if a is equal to 64, then we're going to have a is equal to 32, a is equal to 16. So these are all our recursive calls to mult. So this is mult. A is equal to 8, a is equal to 4, a is equal to 2, and a is equal to 1. So we had for a is equal to 64, how many recursive calls did we have? But weren't we calling the mult twice in one call? I don't know how you did it specifically, but what we did was we made this equal to a variable equals this, and then we returned the variable added together. Yeah, like how we did C plus C. So you're only actually calling it once, and then you're just adding it together. So it's still only one call. Does that make sense? Yeah, it's just the amount of time that you literally actually do mult a divided by 2. So how many recursive calls did we get when a was equal to 64? We called it 6 times, yeah. Who wants another example of this? Okay. So again, this is what most people's codes look like for recursive multiply, and this was like kind of the answer, where we'd have an if statement with the base case if a is equal to 1. And then there's an if else, and there was an else that had a function called mult, and it had something with a divided by 2. And remember, we're not really worried about what b is, because he said based on a is what we're trying to find the number of recursive calls. So if we start out with a being equal to 32, then we go through this function. Okay, if a is equal to 1, a is not equal to 1, so we have to do the else. We have to call a recursive function mult 32 divided by 2, comma b. So this is equivalent to mult 16, whatever. So this is our first call. And now when we look at this, we plug in 16. Okay, if a equals 1, now a equals 16. So we have to go back to the else statement and call mult again. But now we have to call mult for 16 divided by 2, which is 8. And then we look at mult and then the 8. Okay, 8 does not equal 1, so we have to do this call again, which is going to be mult 4, comma, question mark. And then 4 does not equal 1, so we have to do it again, and it's going to be 4 divided by 2 is 2. Mult 2. And then finally, we have 2 divided by 2 is 1. Mult 1. So when we get to 1, we get to this return statement, and we're done with recursive calls, because the function is ended. So when a was equal to 32, we had 1, 2, 3, 4, 5 recursive calls. Alright. If that doesn't make sense to anyone, please say no, so that I can try to explain it differently or ask questions out loud. Does anyone have any questions they want to ask? To the n x with x being 32 in this case. Well, yeah, exactly. It's 2 to the n is equal to a, I guess is easier to say. So, yeah, now put that in terms of n instead of in terms of a. So, yeah, 2, this is kind of the answer, but 2 to the n equals a. So then we need to know n, the number of recursive calls. So how do we do some math to get n by itself, basically? So I think you guys can get it from there. You didn't get how to call it n?
Yeah,
Can you explain what you mean?
actually, so in the question, it has said like your recursive program in terms of the smallest of the two arguments, call it n.
Oh, okay. Well, I don't know what it's called in the prompt. I was saying a because in the original function we call the smaller of the two arguments a, if you remember from last week's homework assignment, where we had integer a and integer b. So when I refer to a, I'm talking about the smaller of the two numbers. And when I was talking about n, I was talking about the number of recursive calls. I don't know what he labeled it as. You guys can change it for that.
Thank you.
Okay, for question 4, are we supposed to prove the algorithm like a theorem? Okay, or give an example and solve it step by step. Hold on, let me look at question 4 real quick. I forgot. Selection, sorry. Basically all you have to do is that thing. I think he did it for the other type of sorting algorithm where I totally forgot what it's called. Where it has like termination base. Does anyone know what that's called? Oh, let me just look. Yeah, use loop invariant. Yeah, exactly. Hope put it in the chat. Just write loop invariant initialization maintenance termination. I think there's like insertion sort he did it with, and you have to do with selection sort. It's like almost the exact same, just change like a few words, and you'll have the answer. Okay, any other questions? Okay, I'm gonna assume that everyone's good. I know some people came in late, so anybody who is late, stay back, and I'm gonna go over question number 2 again because I think that's the hardest one. But anyone else can go. So how do we answer these questions on paper? Okay. So basically, you just need to write a few sentences. There's no like specific way you need to do it. Just make sure that it includes all the information we went over. So let me pull up the question. So what are the fewest and most possible for number 1? Just write literally just write the fewest number of calls and the most number of calls, and then write the two types of arrays that will give you the least and the most. And then the second one, just write a few sentences explaining how you would design your method. The third one, literally just write, pretty much I think you can just write the answer. Number 4, do what we just said. Loop invariant initialization, maintenance, and termination. So it's like a few sentences. And number 5 is just like pretty much math. you use the base case and then you add you add you add 1 to it and then just see if it's equivalent. So just do math for the last one. Does that answer your question? Okay. Yeah, and everyone who doesn't have any questions can go. Yeah, if anyone wants the recording, just send me an email or a Discord message. I'll send it later. I just have to make sure it's all good.